When working out integral problems, often the main thing that we need to do is to try to find a good value for u that will help simplify the problem into one of your common integral formulas. So one thing that I notice in this problem is that I can rewrite the problem as the integral of e to the x over 1 plus e to the x raised to the power of 2 dx. Since when you raise an exponent to another exponent, those exponents become multiplied. Once I notice this, the value of u is often what's inside a parentheses. So let's try setting u equal to e to the x and see if that helps us to simplify. If we first take the derivative, du is equal to e to the x dx. And so that means if we divide both sides by e to the x to solve for dx, dx is equal to du over e to the x. That should be a power, e to the power of x. Okay, so if I leave my e to the x on top for now, but I simplify the bottom to 1 plus u squared, and substitute for dx, du over e to the x, now we have an e to the x on top and an e to the x on bottom, which can cancel out and leave the problem with 1 over 1 plus u squared du. So now I recognize this as an integral formula that is the integral of 1 over a squared plus u squared du is equal to 1 over a arctan of u over a plus c. So my a, because 1 is the same thing as 1 squared, my a will be 1 and my u is just u. So I can rewrite this formula as 1 over, my a is 1, arctan of u, which is u, over a, which is 1, plus c. And then to resubstitute in my e to the x for my u would be arctan of e to the x plus c, which is my final answer. So I hope this step-by-step solution was helpful for you. If it was, please like the video and share with anybody that you think might find this information useful. Also, subscribe to my channel for more homework help YouTube videos. Thanks for watching.